In recent years, several experiments have suggested that the arrow of time might not be as fixed as we once thought. These experiments have challenged our fundamental understanding of time and left physicists puzzled. One such experiment involved quantum entanglement. Another recent experiment involved time crystals. And these are just a few of the many questions that scientists are currently grappling with as they seek to unravel the mysteries of time. To understand why these recent experiments are so significant, it's important to first understand the concept of the arrow of time. It is the idea that time only moves forward and cannot be reversed. This means that events always unfold in a certain order, with the past preceding the present and the present preceding the future. The concept of the arrow of time has its origins in the second law of thermodynamics, which states that in a closed system, entropy or disorder always increases over time. This means that if you were to break a glass, it would be extremely unlikely for the pieces to spontaneously reassemble themselves into a whole glass. Instead, the glass would become more disordered over time, and the pieces would continue to move farther apart. Furthermore, the second law of thermodynamics gives rise to the arrow of time because it means that certain processes are irreversible. For example, if you drop an ice cube into a glass of water, the ice cube will melt and the water will cool down, but you can't reverse this process and unmelt the ice cube or reheat the water back to its original temperature. The arrow of time is also related to the concept of causality, which states that every event is caused by a preceding event. This means that events can't occur out of sequence, and it gives rise to the idea that time only moves forward. So when recent experiments suggest that the arrow of time can be reversed under certain conditions, it challenges our fundamental understanding of the nature of time and how the universe operates. It raises questions about the true nature of causality, entropy, and the underlying laws. Recent experiments have challenged our understanding of the arrow of time, suggesting that time may not be as straightforward as we once thought. As mentioned before, one set of experiments involves quantum entanglement, a phenomenon in which two particles become connected in such a way that the state of one particle is dependent on the state of the other, no matter how far apart they are. In 2019, a team of physicists at the Moscow Institute of Physics and Technology conducted an experiment in which they created two entangled particles and then measured their states at different times. They found that by adjusting certain parameters, they could reverse the order of the measurements, effectively reversing the arrow of time. Another set of experiments involves time crystals, a new type of material that appears to have a built-in temporal structure. Time crystals are essentially materials that oscillate in a repeating pattern, not just in space, but also in time. This means that they have a built-in temporal symmetry that is not present in other types of matter. In 2017, a team of scientists at the University of California, Berkeley, created a time crystal in the lab by manipulating a chain of ions in a magnetic field. They found that the time crystal appeared to violate the second law of thermodynamics by exhibiting a stable, repeating pattern of motion, despite being in a state of disorder. As scientists continue to conduct experiments and push the boundaries of our understanding, we may soon discover even more surprising insights into the nature of time and the universe. The recent findings suggesting that the arrow of time can be reversed under certain conditions have significant implications for our understanding of the universe and our place within it. One of the most exciting possibilities is the potential for new technologies that could harness time reversal. For example, if we can find ways to reverse the arrow of time in a controlled and predictable way, it could lead to new technologies for data storage and encryption. These technologies would be based on the idea of encoding information in the reverse direction of time, which could provide enhanced security and privacy for sensitive data. The findings could also have implications for our understanding of the fundamental laws of physics. If the arrow of time can be reversed, it would challenge our current understanding of the second law of thermodynamics, which states that entropy always increases over time. It could also lead to new insights into the nature of causality and the flow of time. At a deeper level, these findings could force us to rethink our perception of time and the role it plays in the universe. They could lead to new philosophical and scientific debates about the nature of reality and the relationship between consciousness and the physical world. As we've seen, recent experiments have challenged our understanding of the arrow of time and opened up new avenues of research into the nature of time and the universe. But what comes next? Scientists are currently working on a number of exciting projects that could help us to better understand the fundamental nature of time. One area of research is focused on understanding the relationship between quantum mechanics and general relativity, which could help to resolve some of the fundamental contradictions in our current understanding of the universe. Another area of research is focused on developing new technologies that could harness time reversal. This includes developing new materials that exhibit time crystals and exploring the potential applications of these materials in areas such as data storage and encryption. Finally, scientists are also working to develop new experimental techniques that could help us to better understand the arrow of time and the nature of causality. This includes experiments that use quantum entanglement and other quantum phenomena to probe the nature of time at a deeper level. In the coming years, scientists hope to make even more groundbreaking discoveries about the nature of time and the universe. These discoveries could have far-reaching implications for our understanding of the world around us and our place within it. As we continue to push the boundaries of our understanding, we may discover even more surprising insights into the nature of time and the universe.